Hello, welcome to this course on mathematical tools for cognitive sciences. Now, this is a mathematics course, but it would be just basic mathematics up to, let's say, 12th standard mathematics. And it would involve all those mathematical concepts and tools that are useful for studying cognitive sciences. So, either you are studying, let's say, decision making behavior or let's say perception or language, right? You would require some of these mathematical tools in order to, let's say, model behavior or to do statistical inference, and maybe just to analyze behavioral data, right? So this is a very important course for anyone who is an aspiring cognitive science researcher. For example, students who are right now in their bachelor's and they want to pursue a master's or PhD in cognitive sciences, this course is very relevant. And the reason is this, that in cognitive science, students come from different background, for example, from psychology, from biology, right? Um, and one of the thing that happens is that they find it very challenging to start doing cognitive sciences right away, because the cognitive science research is very technical. It would require you to do lot of statistical inference. It would require you to use some mathematics and programming to even to design basic experiments, right? So a, a kind of course like this is a basic mathematics course which will give you a foundation so that you can further learn all those statistical methods and programming. Okay. So after doing this course, you won't be afraid of anything, any technical courses you would do in your career for cognitive sciences, right? So that's the idea of this course, so that you do not have that sort of nervousness around mathematics, and you become confident with mathematical concepts and you start using mathematics in your research, right? So, with this goal, this course would have four parts. In the first part, I will introduce very basics. The first part would be called functions. Okay, so I will start with idea of real numbers. Then we will do some equations, how to solve equations, then how to draw graphs, right? Equation of a straight line, for example. And then we will do some more interesting functions like logarithmic functions, and exponential functions, how to find domain, codomain, and inverse functions, and then also trigonometric functions, which you may find useful in certain areas of research within cognitive science. So that's the first module. So first module is on functions, and that's an important module because without that you would always be a bit hesitant to look at all the mathematical details, right? So first module is functions. Second module would be differentiation. Okay, so that's an basically this is one first module in calculus. So in differentiation, you would learn how to find first order derivative, second order derivative of a function, how to find maxima of a function, and also it would be useful to understand the idea of slope and all those main effect and interaction effect, right? So that's the second part, differentiation. In the third part, I will introduce linear algebra. So I will cover matrices, matrix algebra, and vector algebra. So we'll learn how to multiply matrices, how to do some other operations on matrices, like how to find an inverse matrix. So this is also an important part. We won't go into lot of details of matrices, but at least we will cover some basic, so that you can do some basic operations on matrices and you know how a matrix looks like and why it is important, right? Then we will do some vector algebra, so how to do certain operations on vectors, right? So that's part of this algebra module. Then the after this we will learn integration and multivariable calculus, which is important, for example, to find area under the curve. So to understand that concept, what is area under the curve, this would be an important module. It won't be too long. I think there would be just 3-4 lectures in this module, but we will do it. And the multivariate calculus would introduce it to idea of, for example, the least square method, which we use in linear regression modeling in the frequentist framework. Okay. The final module, which is one of the most important module I consider for this course, and I would spend a lot of time on that. It's called sets and probability, right? Sets, probability, and random variables. So these are three main things that I'm going to cover in this module. So you will learn about sets, how to do operations on sets. For example, you might have heard about union of sets, interaction of sets, right? Those are very important concepts to understand probability as well. And then I will introduce probability theory, probability distributions, random variables, right? And how these things are used for doing statistical inference, right? So I will leave this course, I will conclude this course at the point where you are ready to take up statistical inference, right? So in a way, this course will prepare you for more advanced coursework in cognitive sciences, in let's say statistical methods, and in cognitive modeling or any other computational modeling, right? So this is but very basic. We are not going to go into details, theorems, and proofs a lot. But idea is this: that you practice all these concepts that you might have done in your high school, but you practice them during this course, and you become more confident about your mathematical skills, so that you can take up on research in cognitive sciences, right? So one very important advice I would give you while doing this course is that um, you should take out some time on each topic. Even if, let's say, I will give you some assignments every week, but even if, let's say, assignment has only 10 questions, you should practice more. Okay, I can give you some additional questions as well as optional questions in the assignment. So you should practice more. So make it like every week you are practicing for at least 4 or 5 hours. Okay, that would be really useful for doing this course, right? If you don't practice, then you won't be able to learn mathematics, and you won't become confident that you can do all these things, right? So practice at least 4 or 5 hours every week. Yeah? That's an important thing while doing a mathematics course, right? Now the goal of the course is to apply these mathematical tools in cognitive science research. So most of the examples I will be taking to explain functions, sets, probability, inference, and calculus, right? Most of these examples would be from cognitive sciences, right? So this course is most adequate for students who are, let's say, pursuing bachelors in psychology or some cognitive sciences or linguistics, or let's say biology, life sciences, right? And who aspire to work in cognitive sciences, or also the existing master's students who are already working in cognitive sciences, or PhD students who are doing cognitive sciences already. This course is also useful for them, unless they have done all this stuff already, right? So yeah, that's it from my side. So this is an introduction to the course. I will be your instructor for this course. My name is Himanshu Yadav. I work at Cognitive Science Department in IIT Kanpur, and my area of research is language processing in humans and individual differences. Um, my work involves psycholinguistic experimentation as well as computational modeling. So I use most of these mathematical tools and programming for my research, right? So I've taught this course before. So the only thing that I realized that if students practice enough, let's say 4 or 5 hours at least in a week, then they become very confident even if they did not have any background in mathematics before, right? So all the best, and I look forward to have you in this course. And let's make good use of this course and time. And all the best. Thank you.